Hello everyone. So today we will be discussing TIFR 2020's first problem, the IPHD exam's first problem, and this problem requires a little bit of Stolz-Cesaro theorem, uh, which we will see eventually. Okay. So here, as you can see, we have this sequence An and the sequence Bn, and uh, I have to kind of find out what is the limit of my Bn. All right. So as we know that this is the Stolz-Cesaro theorem, you are welcome to pause it and kind of give it quite a read. So one of the things that we will use from the Stolz-Cesaro theorem is this, that uh, if I have a sequence of positive reals, then limit n tends to infinity, summation over ci I equals to 1 to n by n is equals to limit n tends to infinity Cn. Okay, so where it's a sequence of positive real numbers. Cn positive real numbers. All right. So this is one of the you can say kind of the averaging law, but this is a very specific case of the entire Stolz-Cesaro theorem. So as you can see, that from here you can kind of understand that that in particular form, in this particular form, if I just replace each of these bi's with one, then this is nothing but n by one. All right. So the in particular case is that if n by bn is a limit, has a limit, that means if I have if n has a limit, then this is nothing but the Stolz-Cesaro theorem. All right. This is a very specific case of the Stolz-Cesaro. Now, how will we actually use it? So as you can see that the bn, if you write it down properly, it looks like this. So it's practically, let us first write down the way it has been given. Summation over 1 by ei, I equals to 1 to n. All right. So now each of these EIs are defined like what? Each of these EIs are defined like this. So it's practically, as you can see, the EIs are defined like 2 to the power n plus 3 to the power n to the power 1 to the 1 by n. So that means EIs are 2 to the power I plus 3 to the power I 1 by I equals to 1 to n. So by simplifying it, so you will see that we have 3n I summation over 1 plus 2 by 3 whole to the power I to the power 1 by I. All right, so I equals to 1 to n. Now the entire essence of this problem, where will I actually use it? You can kind of see a very obvious place to use this portion. That is, if I take this n in the denominator. All right. So if I take it, and since everything is kind of bounded, the above and lower, if I take the denominator, if I take n to the denominator, so what happens is that now we are left with something like this: 3 by summation over 1 plus 2 by 3 whole to the power I to the power 1 by I equals to 1 to n by n. Now, by the specifications of Cesaro's theorem, if you take limit n tends to infinity, this will actually be free. The reason is, by Cesaro's theorem, this will become 1. All right. So here we are actually using this argument, that summation over ci by n. So if you take summation over ci by n, this will be your ai limit. So practically limit n tends to infinity a n. All right. So this will be, this is nothing but limit n tends to infinity 1 plus 2 by 3 whole to the power n to the power 1 by n, and this limit goes to 1. Hence the entire sequence is limit, the limit n tends to infinity dn, it will be 3. So practically, if you want to give a read about the Stolz, if you want to read about the Stolz-Cesaro theorem, you can actually look at this page. But for this problem, only this specifications are needed. So since all the functions above and below are bounded, and you can kind of use the averaging, you can kind of use the specific case of the Stolz-Cesaro theorem. From there, you will get that the sequence is convergent and it converges to P. Okay, so this is it for today. We will meet next time with another problem of TIFR.